Hi, welcome to Teardown Tuesday. The venerable DS1052E from Rigol, first released in about 2008, so it's around 6 years old or thereabouts, older than my blog, and I reviewed this in my very first EEVblog #1 video. As horrible as that was, yes, I reviewed it way back then, and it was the leading low-cost price performance scope back then. Back when this was originally released, it was $800 price point. A lot of people don't realize that. They think it's always been around half that, or that $400 price point people have been used to in the last few years. But anyway, this is really long in the tooth, and Rigol have finally released basically a complete replacement for it, and it's got a ton of stuff, a ton of bells and whistles. So although Rigol still officially sell this and support it, it seems you'd be crazy to buy one, because they've released just recently the new DS1054Z. So it's the Z series, and the 4 is a giveaway for the 4 channels instead of 2. The fantastic thing about this is its price point is very similar to the 1052E that it's been for quite a long time. It's $399 US. Unbelievable. That price varies depending on the country. It's a bit more than that here in Australia, but still well under $500. So it is the leading price performance scope on the market, it seems. So although this isn't a review, yes, I'll say a couple of things about it. It's built as good or better than the 1052E, or so it seems. We haven't taken it apart yet to find out what it's like inside, but it feels like a really solid instrument. It's got 4 channels, it's got a buttload of memory on it, and it's got the intensity graded display. Not quite as many levels as the DS2000 series, but still for $399, 4 channel, 50 megahertz, so the same bandwidth as the 1052E. There is a 100 megahertz model available as well. 4 channels, incredible for the price point. When I was a boy, scopes were always around about, I've done a video on this, so it's still around about that $800 price point level. 20 megahertz dual trace analog Crow back then was the entry level scope, and around about the $800, and that's what this one was released at. But this one is now half that. It's crazy for 4 channels, and it's got a ton of memory in it. It's got the intensity graded display. It's got optional software serial decoding and all sorts of stuff. It's got segmented memory. Doesn't have quite the nice segmented memory controls that the DS2000 has, but still, geez, it's impossible to beat. The value for money for this thing, is it any good? I don't know. Have to do a full review of it. So if this thing is any good, and I have no reason to doubt that it wouldn't be, might have a few bugs and things, as almost all scopes do these days with the complexity in the damn things. Anyway, Rigol have been refining the scopes. I mean, even before this one, this was not their first digital scope. It started with I think the 3000 or 5000 series, which was a longer one like this. Been slowly refining them. Agilent really helped them out there, and well, they're regretting that big time now, because Rigol are one of the major players in the market. And well, if this thing is as good as the specs claim, and if it's built well, then it is impossible to beat in today's market. I think 4 channels, 50 megahertz for under $400 with a crap load of memory and all sorts of functionality, intensity graded display. Oh man, I don't know, you youngsters these days, the amount of scope you can get for the money, just ridiculous. Couldn't even be dreamed of 5 years ago. And this one is on loan from John South at Emona Instruments, who you should know, the dealers in Australia. So thank you very much, John, for loaning me this. It's the only one he's got, I think, in the country at the moment. Yes, I have ordered one, and I will be getting my own unit when they hit the country, but this is a demo unit, so he's going to let us take it apart and review it. Awesome. So anyway, is it any good? Let's find out. There's only one way to do that. You know what we say here on the EEVblog. Don't turn it on, take it apart. And here it is compared to the DS1052E. It's little smidgen wider, nothing in it. It's exactly the same height, and it's looks like it's maybe a little bit thinner. It doesn't have these protruding bits out the back because this had the feet on the back so it could sit flat like that. And this one doesn't need that because all the stuff is recessed down in there. But apart from that, oh, and it's a little bit heavier. Well, it's a reasonable amount heavier. So, you know, it's basically the same form factor as the 1052E, but we've now got 4 channels and a bigger display. Look at that. Ah, beautiful. And that there just gives you a good overview of how much bigger that screen is, more usable. We've got the soft function buttons down here, more of them. We've got the 4 channels instead of the 2, but no external trigger, of course. You have to sacrifice one of your channels here if you want external triggering, but still, you know, you can't complain on such a small form factor. It's brilliant. And yes, if I'm not careful, I will get carried away into doing a mini review here. Anyway, all the buttons are pushable. It feels just as good a quality as the 1052E, really. And, you know, Rigol do a pretty decent, you know, low-end quality feel to them. And certainly that nice, hefty weight just feels like it's nice and solid. So let's take a look inside. Oh, and of course I forgot to mention LXI LAN as standard for under $400. Gotta be kidding me. And very similar design feet to the 1052E, which are okay. You know, they could be better. Nice, decent rubber feet on the back there. And yeah, it's not too shabby at all. And of course it's got universal input voltage and frequency as you'd expect, and claims about 50 watts maximum. What it actually takes, haven't measured it yet. And it turns out the answer to that question is 22 watts or thereabouts, with all 4 channels running at the fastest time base. But if you want to know the apparent power, well, there we go, about 40 and a half. Because the corresponding power factor, there it is about 0.55. And not that crash hot. But you'll be pleased to know, yes, it does have a real clunking power switch. It draws nothing when you turn it off. Yay. As for getting this sucker apart, looks like very same as the 1052E. We've got 2 Torx bits there and a couple hidden under the handle down in there. And yes, that is a warranty void if removed sticker. It's lucky then I'm wearing my warranty void if not removed t-shirt, available on the EEVblog store, link down below. One small step for a man, one giant leap for mankind. Yeah. And thankfully the power switch is on the front, so there's nothing on the top here that you can break like you can on the 1052E and like I did on mine. Oops. But ta-da! We're in, and that weight, yep, look at that. Metal everywhere. Beautifully shielded. Love it. And you'll notice that it's only got the pass, fail and trigger output here. Doesn't have the source outputs like the other, the higher end 1000Z models do. And no, you cannot get this 1054Z with the logic analyzer or the source options. Not available. Not sure what that one is for. I've never seen it. It's got the you know, PCB down in there, so I don't know, maybe they thought of something else and left it off. And you'll notice that on the front panel here, of course, it doesn't have the 2 extra buttons, which some of the higher end models do. It'll have the logic analyzer button and the source button as well. They are missing on this model because it's not even an option. And look at our lovely RFI gaskets down in there for the USB connector and the Ethernet. Yep, they've done that properly. It really is quite a belt and braces approach to the whole thing. They've just shielded everything. And there's our big clunking main switch down in there, just switching the active, the brown wire there, going straight into it. So, yep, thumbs up. And that real clunking power switch is different to the slightly higher end DS1052 series, which of course has the soft power button on it. So, hey, it must be cheaper to whack in just a manual switch like that. And they've used a proper fuse and rated and compliant IEC input connector, no problems whatsoever. Everything's nicely heat shrunk and nice and tidy and short, so yeah, no problems whatsoever. And if you can read down in there, we have board version 1.01. So that's pretty handy. You can actually see what revision hardware board you've got by just taking the back off. You don't have to take any metal, but I believe it shows you that on the info display anyway. It's got that ID inside, and the software can tell you what hardware version you've actually got. And if I take off a whole bunch of screws right around the outside here, once again, Torx. Come on, you can do it. It's going to come off, and we can't. Yeah, we have to disconnect those, but we're in like Flynn. Errol, that is. First of all, just the main power supply and wiring inside this thing, and isn't that beautifully neat and tidy? It's exactly the length you need. They're cable tied. They've even cable tied down the fan there just to hold it in place, stop it flapping around in the breeze, and down in there, the earthing, beautiful, look at that. It's probably got shake-proof washers in there, probably. I think I can see it anyway, properly crimped and all bonded directly down to there. And yep, that's professional, but that's what you'd expect from a quality brand unit, and it delivers. And in terms of thermal design, we've got a Sunon brand fan here, so it's not a no-namer, and a huge grill over here, and of course grills on the side of the power supply here, which we'll take apart in a second. Well, take apart right now. Ta-da! Oh, look at that. Nice. Oh, that's very clean, isn't it? Oh, like that. Anyway, yeah, so, you know, if you weren't happy with the noise on this thing, you could actually replace it with a silent, well, a lower noise one. But anyway, we need to investigate that, but it gets hot. And if that part gets hot, this part gets cold. Anyway, there's quite a lot of space inside here, actually, which is good for airflow, but it also kind of just makes me think, well, if you're really super keen, you could design a new board to go in there and have like a battery powered version of it, some sort of aftermarket kit to do that. Perhaps there's a little market for that. Anyway, interesting that we have, check this out, all of the Chinese characters down there. Sorry, I don't know my Chinese characters, of course, but for the various voltage outputs down in there, that's just rather unusual. I know this is made in China, but, well, no, there are, maybe on the other side, it's got trig there, it's got fan, so it's got a couple of other, a fan, is it? Interesting, why? But anyway, yeah, Chinese characters instead of just, you know, ground and plus 5 volts and all that sort of jazz. And that's version 1.01 for those playing along at home. And as we'll see on the main board as well, this one has another little graphic on there. Another bird, which we saw in the DS1000 teardown, but this is a different bird. And I think it was the code name for the project. I can't remember exactly what type of bird it was, and I'm not actually sure what type of bird that is. I don't know my birds. Sorry for all you bird people out there. But that's probably the code name for this 1000. This new 1000 series. Anyway, look, we have some nice common mode chokes here. They're Celastic down, very nice. We've got input protection. We've got all the requisite stuff happening. Look, we've got the high voltage isolation slots between our bridge rectifier directly on the input there, and it all looks very neat and tidy. It really does. Only one issue. And of course they're going for the Capzon caps, not to be confused with a very similar sounding one which are actually cheaper yet again. So yeah, they're not the best caps, let's say that, but hey, you know, the ventilation and thermals look pretty good on this, so yeah, okay. Well, they are 105 degree C rated one, and I guess the good thing is there's a lot of companies like mix and match all their manufacturers of capacitors, but not Rigol in this case. They've stuck with all of their output caps as well, not just the input main filter cap. All the output caps are exactly the same brand Capzon and exactly the same series. So yeah, at least they've stuck with it and they've specified them, which is good, rather than just sticking in any brand cap willy-nilly that they can get, you know, this week at the markets or whatever. So yeah, that's the positive side. And we've got our filtering down there, another high voltage isolation slot down to the mains earth there. Nice little attention to detail. Got our requisite input protection, and yeah, it's all going on. And there's the transformer. Looks like it's quite reasonable quality, and the opto isolators there, no issue at all. Okay, let's have a look at the main board, and as I said, this is version 1.01 of the hardware, and obviously we're missing the logic analyzer part. Huge BGA here missing. It's most likely an FPGA, and the connector for the logic analyzer, so you can forget about modding this to add the logic analyzer functionality. It's just not there. End of story. Although obviously they are still using the same PCB across all of the 1000 series models here. So yeah, some of the higher end ones do have the logic analyzer capability as an option, but this one, yep, to cut the cost, they've just haven't installed the chip and haven't installed the memory, and that's actually, and a couple of local regulators for that, and well, that's about it. But hey, that shaves cost off, and that's what they've done here. That's how they can sell this thing for $399 retail. Now, if we have a look at the whole thing, we've obviously got our 4 analog channels under the can, and we'll take a good look at that later. But you'll notice that the basic layout isn't as complicated as the DS2000, of course. There's quite a few things missing. The DS2000 had 2 main FPGAs here, one dedicated directly for the display processing, and well, that's not on the top side here. Then they've got a smaller FPGA here for the acquisition engine. Yeah, so it's much more simplistic, although they're still getting 30,000 waveform updates per second out of this thing. So yeah, they might have rejigged their architecture and how they implement it a little bit to still get quite really decent performance, especially for the price point. Absolutely incredible. Maximum of 30,000 waveforms per second for, you know, under $400 with the 4 channels and everything else. Oh, it's crazy. Anyway, they've used the Pro ASIC 3 again from Actel. But it looks like a smaller device than what we did before. We've got our applications processor here. We'll take a good look at those. But yeah, it's much simpler, as you'd expect, being built down to a lower price point than the DS2000. And you'll also notice that that looks like our ADC in there. It's got the 4 channels with the differential pair going out to each of those. I'll show you a close-up, but it's much smaller, much different than the huge rebadged one we saw in the DS2000. Big difference there. And there it is. It's got a custom Rigol part number on it, and well, no, it's not going to be most likely not a custom Rigol part. It's just a rebadged part number from a different manufacturer. I think the one in the DS2000 was from National Semiconductor, if I remember rightly. So for those who want to go and reverse engineer that one, and you can tell just from the pinouts, you can see where the differential pairs are coming in here. These are our 4 analog channels coming in, differential, and these are our data output channels and other stuff going around here. And well, we've just got some decoupling and power. There's not a huge amount to it actually, but yes, it is one ADC across all 4 channels. So yes, when you turn on all 4 channels, you don't get the full 1 gig sample per second. It drops down to 250 meg samples per second. And under that heatsink, after I clear away the thermal compound, no surprises, a Xilinx Spartan 6 and XC6S LX25. And that Pro ASIC 3 from Actel is an A3P030. Now this is really interesting. Up near this Pro ASIC 3, look what we have here. Hardware version, and then what looks like a whole bunch of configuration resistors. So that's really interesting. Look, they've even got =1 =0 next to it. Now, I don't think they're just pull-ups for like this JTAG interface or whatever we've got here. That's what likely that is. And SP version as well. That's really interesting. Are they configuring this thing just based on the position of the hardware jumpers? That'd be really like the difference between the 50 and the 100 megahertz version. That'd be interesting. And as far as the applications processor goes, they've completely changed it. If you remember in the DS2000 series, it was a Blackfin DSP processor, but now they've gone with a Freescale processor in this thing. That's a big change. That's rather curious why on these different platforms they choose different processors. That's just making it hard for themselves, but maybe that's what they have to do to meet the price target on this lower end model, because the DS2000 is in the $1,000 plus range. This one is sort of, you know, your $400 to $1,000 price range. So they've got to shave costs somewhere. So maybe they've retooled it to use the Freescale processor. Must be cheaper. So that's an IMX283 applications processor. It's quite a beast. It's an ARM9 operating in about 450 megahertz, or capable of that, and it's got all sorts of stuff built in. It's got all the LCD controllers, it's got Ethernet PHY and all sorts of jazz built in. So really quite a powerful thing, but different to that Blackfin DSP. And under the can for the analog front end, which people are always keen to have a look at, no surprises of course, you always get this 4 absolutely identical channels between them, and it looks very similar to the one used in the original 1052E. Now, of course, you would expect this front end to be more like the DS1052E than the DS2000, because the DS2000 is capable of double the bandwidth of this thing, and that's exactly what we see, because if you compare it, here we go, with a photo of the DS2000 front end, it's totally different. The DS2000 has dual relays, it's got dual adjustable trimmer caps in there, and yeah, it's just a totally different beast. Whereas if you compare it with a photo, here we go, of the DS1052E, you'll notice that it's very similar. Only got the one relay, only got the one adjustment cap, very similar amount of passive circuitry and stuff like that. There are differences. It is a different topology by the looks of it, assuming that there's no components on the other side, that they're all on the top, and that's what we've seen in previous designs, so I expect this one to be no different. Yeah, it is going to be slightly different again, but yeah, it's these are 100 megahertz rated front ends, and yes, it is software limited to 50 megahertz. So it's probably going to have that varicap diode in there again to adjust the bandwidth, which would be my guess. And then when you buy the software license to get the 100 megahertz version, bingo, it just toggles that line to the varicap diode and adjusts the bandwidth on the front end. And if you have a look down in there, we can see there's one diode down in there, so possibly is that it? That's the only one that's marked as a diode there, so I don't know. And there's certainly less in here than the 1052E. We've got what looks like our driver here, because there we go, it's driving that pair up there, which then goes out. There's our output going through the bottom of our can there, but basically that's the only like amplifier chip in there. We've got a 4053 MUX here, 4000 series CMOS, but everything else is discrete. So they're doing a discrete transistor FET front end, of course, like they were doing on the 1052E, but they also use an AD8510 on the 1052E, which doesn't seem to be there. So it looks like it's a different topology. So if we look at the DS1052E schematic here, drawn by A. Helene, thank you very much. He's reverse engineered this, and look at, well, what's here and what's missing in this Z series. I mean, we've got no, I mean, they use an AD8510 high-speed JFET amp on the input here. We haven't got that. There's nothing like that here. Down on, here we go, they've got a programmable gain amp. It's an AD8370, a digitally programmable gain amp, and then they've got an output driver, the LMH6552. It is totally different. We've got none of that. We've only got one active device in all of this, so it wouldn't surprise me that they got the same JFET amp on the input side here. They'd have something very similar to that, but looks like they've at least done away with the input amp, and all they've got is basically an output driver. There's no programmable gain amp anymore. And there we go, we have a Texas Instruments part, and it's got P27444K A6CP, and I'm not having too much luck decoding that at first try. And there's lots of very similar transistors on here. Look, 7AT, part in there, absolutely everywhere, all over here, and there's a couple of others, and yeah, go for your life, but it's basically, there's very little in this thing at all. We've got our relay down the bottom, our solid state relay, and not much. It's one of the simplest front ends I've seen on these Rigol scopes. And also you would have noticed that there's no Rigol rebranded parts inside here, so they're not trying to obfuscate what parts they're actually using. Yeah, you could pretty much, from the photos, you could easily reverse engineer this channel if you put the time into it. So the interesting thing is that all of these Rigol scopes I seem to have opened all seem to use a different topology front end. So it's not like they designed one years ago and then just stuck with it. They've, they're really optimized. It seems like they're optimizing it all the time for the to meet the price target, and that's not surprising at all. With the DS2000, all those analog devices parts and those national parts, they don't come cheap, especially when you've got a couple of them in your bill of materials, and well, you're trying to save every dollar, trying to meet a really aggressive price point, and well, they had to redesign for this one, hence why we've probably got just one active part. Transistors are usually quite cheap. It's just much trickier to design and compensate using those. So, but save cost, and of course the that only cost a cent for the 74000 series, not even that. So they're really optimized down. I like it. And you also would have noted that there's no local voltage regulation on these individual front ends either. Likely they've got a 2.5 linear regulator over here, so that's likely powering all 4 channels. So they don't have the extra low noise one like the DS2000 does, because it's got the 500 microvolt per division raise. So it needs a lower noise linear regulator specifically designed for the task, and a bunch of other little touches to make it low noise. This one only 1 millivolt per division, just like your standard scope, so they didn't have to do anything special here. Once again, saving the cost. I wouldn't have expected the 500 microvolts per division capability in this ultra low end one. And I'm just trying to get the rest of it apart, and like I've done all the screws out of here, and unfortunately the board doesn't lift up because the BNCs on the front panel are caught in there and there's no accessible nuts on the front, so I have to take all of the cage out by the looks of it before I can unscrew those to get the main board out. Oh goodness. And ta-da, here's our front panel board, and you can see the extra switches down in here. They've even populated the LEDs on there for those extra 2 switches, which are present on the higher end model but aren't present down here. So they've actually cut those out. Look, they've actually cut the buttons out of the membrane there. That's hilarious. But they've installed the LED. So somebody who did the pick and place file for this thing forgot to remove those 2 LEDs. So oops, spending a couple of extra points of a cent. For those curious to know what rotary encoder they're using there, I'm not sure of that brand offhand. Anyway, if anyone wants to look that one up, by all means, go for it. And to get that main board out, I've had to unscrew the LCD from here and access the flat flex through this cutout on the back there. A little bit annoying, but yeah, I can understand why they've done it. And that is the LCD, if that's an identifier for those interested. Well, there you go. That completely changes the equation on the front end. Look at all the stuff that they got on the back here. Actually, as it turns out, it doesn't change the equation a huge amount. Look, if we split it down the middle here, we've got some common parts for 2 channels. We've got an analog devices part here, which turns out to be a digital potentiometer. We've got another, not sure if it's the exact same part number as what's on the top there, the TI part. I haven't looked at it. We've got a TL072 and another 4053. And those 3 parts there are shared between 2 channels and then duplicated on the other 2 channels next to it. So the only additional active component on here is another one of these beasties. Everything else is once again all passive and transistor based stuff all around here. So it's still not a huge amount. And there we go, we have an analog devices AD5207, and as I said, that's a digital potentiometer, 256 step digital potentiometer. Weird. Aha, as for that beast there, HA595, it's just a 74 HC595. Exactly what's used in the previous model. So really, that is not another active amplifier. I mean, up here we've got a TL072. I mean, that's not going to be, it's going to be used for offset or something like that. It's not going to be used as any part of the signal chain. So still, we have a complete 100 megahertz amplifier. Front end is discrete transistor based. And here we go. We have found another one of these TI parts, and it is a quad op amp. That's what I was starting to think that it probably was, and it looks like it is. So I can only presume that's a TLV274 from TI. It's only like a low power 3 megahertz bandwidth quad op amp. Aha, and on a second look at the front of the board here on this analog channel, once again we've got ourselves that TLV274, which I think it is, and wow, what I thought I was a bit misled before. The differential output here is not coming from here. I thought it was. I thought those tracks were going under there, but they're not. They're coming from this transistor amp here. So obviously it looks like they've got a complete transistor solution from go to woe here. Very interesting. Then, well, I can really see how they've gotten the price point down on this sucker. And as for the rest of the board here, well, it is pretty bland. We've just got, more local regulation around here. Nothing fancy at all. We've just got our decoupling under there. Nothing at all more on the analog channel side of things. And we've just got an extra memory there for our application processor. Is that that could be the flash? Anyway, I can confirm that the flat flex, the display, there's the flat flex for the display. It, of course, if you flip it over, there's the termination resistors there, connected directly into that Freescale applications processor down in there, as opposed to the separate FPGA display processor that they used in the DS2000. So once again, completely different architecture. This isn't responsible for the 30,000 waveform updates per second, because this is just the display. You're not actually displaying 30,000 waveforms per second on the screen. It's not updating 30,000 times per second, but that's all happening inside the FPGA capture engine over here, and then it's displaying at a lower rate, of course. And yep, that's our Hynix flash memory for the Freescale applications processor, as suspected. And what's interesting, this is the main capture FPGA around here, so they've got no extra memory on the bottom, so they've only got the one memory chip on the top. If we flip it over like that, there we go. That's it down there. Well, they've got two, one here and one here. And that Cypress part there is a 9 megbit SRAM in a 256 kbit times 32 configuration. So that's almost certainly used for the buffer for the variable intensity display to capture all the data and then, overlay it on top of each other and do the color grading and all that sort of jazz. And here's our only sample memory chip. It's a beast though. It's 512 megbit DDR2. And of course, that 512 megbits equates to 64 megabytes, assuming an 8-bit sample, of course, and you divide that by all 4 channels, obviously have to be stored in there. We've got 16 megabytes or meg samples per channel, and this thing has 12 meg points of memory and an optional 24, so I'm not sure where they're getting the 24 from. And this flat flex over here goes off to the side soft buttons on the left hand side of the screen, and I find it interesting that they've got a little cutout there for a card edge connector which tests in, obviously some sort of part of the test system for the board, but they don't do the same thing for the other keyboard, the main, the rotary encoder and all the other keys. They don't do the same thing over here, so that's interesting. So that kind of makes me speculate that these keys over here possibly have some sort of factory testing capability or something like that, because they're the ones that go off to that card edge connector, which they presumably, you know, they plug that in for a reason, some sort of jig or something like that at production. It may be like a debugging thing during the design process, but anyway, so there's something special about these, I suspect. There's our main crystal oscillator there, and our PLL for raising that up. And look, we've got a couple of more of these TLV 274 quad op amps here, so they've used those a lot. So there you have it. That's a look inside the new DS1054Z, or essentially the DS1000Z series, be it with the extra logic analyzer down here or whatever. It's just got the extra chips populated. And the other thing I didn't mention is the source outputs. Look, they've got a cutout over here, and well, the board, the source board, I think I've heard mention that there's a separate board or something like that that has the source connections, but I can't find any connector there that it would go to. So that's interesting. So you almost have to wonder, is the S model with the source output a completely different board? I don't know, because yeah, there is no connection to put a second board for the source module there. So that's very curious. And well, I can't fault this sucker at all, really. I mean, it is very nicely engineered and built, and the soldering quality is excellent. And for $395 for all the capability it offers, well, yeah, I couldn't even probably nitpick on this if I tried, apart from maybe the caps on caps in the power supply. But geez, thumbs up. Anyway, I hope you enjoyed that teardown. As always, if you liked it, please give it a big thumbs up on YouTube, because that helps a lot. And if you want to discuss it, EEVblog forum is the place to do it. Link is down below. And as always, high-res teardown photos of all of this. I usually do them as I go along, are linked on EEVblog.com. That's down below as well. Hope you enjoyed it. Catch you next time.